Hello. Let me just make a few changes. Hold on. Hmm. So yesterday I did a stream and for some reason it switched off and I didn't know. Then I was recording the entire time without knowing that the stream isn't actually working. So I'm gonna redo this stream again. I'm just setting up my chat right now. Okay. Right. Okay. So thin stroke, Zen mode. Now. So I think last time I did, let me just check the contents. I did it till the chain rule. I don't know if I did inverse functions. And I shall open the answer key. Also, I streamed inverse functions yesterday, but for some reason it did not save. So let's study this then. The derivative of an inverse function. We begin by considering a function and its inverse. If f of x is both invertible and differentiable, it seems reasonable that the inverse of f of x is also differentiable. Okay, and the derivative of the inverse is 1 over the derivative of f. And using the inverse as the input. So the derivative of the inverse at a is derivative of f and then the inverse. I think I read there's another way to derive this, since x is this, then take the derivative of x with both sides, then you get this. Using the chain rule, derivative of the outside times the derivative of the inside. And then I guess you can make this the subject. That's how you derive. And then it talks about extending the power rule to rational exponents. Okay, derivative of inverse trigonometric functions. I think I should remember these. So derivative of arcsine is 1 over, it's this, I think. Yeah. And then arc cos is negative. Arc cos is negative 1. Then the next, why is this taking so long to load? Okay. Then tan is plus x square derivative the tangent arctan 1 plus, and then cot and then secant arc secant is this. So it's, I think, positive 1. Then cosecant is negative 1. Now let's do some exercises. They showed some examples here. Right, let's try doing this. Take a picture. Right. So I will write the inverse function like this because it's easier. So g of x plus 2 over x. So in the I'm gonna do this x and then minus is 2 and then take the x out. Yeah. And then what? So then the inverse is like this. And then the derivative of the inverse is, I will write it like this. Derivative is derivative, I think it's this, derivative of the outside and then the inside. So square, and then I can rewrite it like this because this is mentioned in here. Get to like that. And then using the previous formula, write it like that, and yeah, this is hold on. Wait, I can rewrite this another way. The derivative is minus 2. Can write this like minus half. Write it like that. And then half and then I can do this. Now going back to the previous function, is 1 over derivative of g is this okay. Square, which is, look at this, so minus 2 x is square. That means this. So this is how we apply the inverse function theorem to find the derivative. You also have to open this now. So x plus 2 over x, nope. No, wait. Sorry. This is x square. Let's see the answer. Yeah, minus 2 over x squared. Okay, let's do some exercises. Find the derivative of h of x squared h of x okay, so the derivative is the derivative of the first times the second plus the first times the derivative of the second. Is this correct? Yes. So that's it, that's the derivative. Or is there a way to simplify? Nope, this is the answer. Okay, questions? Copy and close. Oops. First question. Wait, hold on. Let me check some things. Okay. Yeah. 265. So we are finding the derivative at 1. Times 3 is 6. And then at 1 it's just 6. Now we are finding the inverse. So this is correct. Yeah. So then is I would actually write it like this. Right. Then use part B to find the derivative. Okay. Um, the derivative of this is 1 over derivative of f. We are finding the derivative at f of a. Which is -1 and -1 is just 1, and at -1 is so 1/6. Let me see. What question is this? 265? Yeah. Next one is sin x. And then a is 0. Derivative of sin is cos. Now f of 0 is 0. The derivative is 1. I'll write it f of a. Now the inverse, which is basically arcsine. And the derivative of the inverse, which is basically 1 over and then what? You have to find it at f of a is 0. Zero 8. This is 0. So the derivative at 0 is just 1. Yeah. Should I do more? Let's see. A local movie theater with a 30-foot high screen that is 10 feet above a person's eye level when seated has a viewing angle of theta given by this, where x is the distance in feet away from the movie screen that the person is sitting. Okay, let's write it down. Question 299. So theta is theta is basically this angle minus this angle. Now I'll write this as x. So cotangent is adjacent over opposite, I think. and then I will write it. And the derivative of this is I'll try to remember. It's minus 1. Is it this? Cotangent 1 plus x square. So 1 plus x square minus minus and minus cancel. Then derivative of the outside times the derivative of the inside. So 1 over 40 over 10. Then this is so I'm correct. If I square both sides, then I multiply both sides with 100. Now what? This is okay. Let's do the last one. The last one is where the derivative is 0. So wait, hold on. Nope, made a mistake. I'm finding the derivative at 0. I mean when derivative is equal to 0. That's when these two are equal. So now for this in 1200, check the answers. 299. Yeah, 28. Let's do the next chapter. Implicit differentiation. In most discussions of math, if the dependent variable y is a function of the independent variable x, we express y in terms of x. If this is the case, we say that y is an explicit function of x. For example, we write the equation y is equal to x squared plus 1. We are defining y explicitly in terms of x. On the other hand, if the relationship between the function y and the variable x is expressed by an equation where y is not expressed entirely in terms of x, we say that the equation defines y implicitly in terms of x. For example, y minus x squared equals 1 defines the function y equals x squared plus 1 implicitly. Okay. Implicit differentiation allows us to find slopes of tangent curves that are not clearly functions. They fail the vertical line test. Okay. Hold on. Assuming that y is defined implicitly by the equation x squared plus y squared equals 25, find dy over dx. So this is derivative of the outside times the derivative of the inside. Minus 2x minus y. Wait, hold on. We can take the 2 out, right? Is this it? Yeah, the answer is correct. Finding the second derivative. The thing is, y is defined in terms of x. low. I will write this as -6 low D high minus high D low on bottom squared. Which is minus y xy squared like that. Should open up this. Then this is minus x squared is this it? How is it? Wait, hold on. Is it correct so far? X squared is 25 minus y squared. I think I made it more complicated than it's supposed to be. Why is this glitching so much? Why is it 25 over y cubed? So this part was correct, I think. No, it wasn't. Oh wait, it's bottom squared. Low d high minus id low upon bottom squared. It's lagging so much. So minus y plus x and then 25. Oops. No. Minus y. Is this correct? You have this. Hold on. Yeah. Okay. I think with implicit differentiation, you can't just take the variable out. Like if it's the it's something like this. And then you have with implicit differentiation you cannot treat y as a constant because y depends on x. These two depend on each other. If this was a separate variable not related to x, then you can take it out. Okay, exercises. 301. 6x squared plus 3y squared. Whoops. Now derivate both sides. 3 times 2. Derivative of the outside times the inside. Then 0. Okay, let's do 3 or 5. Question 3 or 5. And then derivate both sides. And then derivative of the first. Plus the first times the derivative of the second. Outside times the derivative of the inside, which is just 1. And then over here, derivative of the first times the second, plus the first times the derivative of the second, and plus 0. So bringing this to this side, and then bringing this to this side. Y I think this is the answer. 3 or 5. Y minus y over, y minus y over 2 is plus 4. Yeah. And then the next one, 307. It's xy. y square plus 2. So derive both sides with respect to x. Then derivative of the first times the second plus the first times the derivative of the second. Derivative of sine is cos. Derivative of the outside times the inside. This is derivative of the first times the second. That's the first times the derivative of the second. This is equal to 2y times the derivative of y with respect to x. Why is it so laggy? Then plus 0. Okay. So dy by dx sine xy. I'll bring this to the other side. Plus it with y square and then let's start with is this correct? I have no clue. If I make one mistake, it's going to have the snowball effect. Derivative of the y, derivative of the first times the second, plus the first times the derivative of the second, derivative of the outside times the derivative of the inside. What's the derivative of the inside? First times the second. Derivative of the first times the second, which is y, plus the second times the derivative of the first. Doesn't feel correct though. This is the answer I'm getting. Oops, this is minus. If this is minus, then signs here will be flipped. So 2y minus sine xy minus xy cos xy. Yeah, this is correct. Next chapter. Derivative of exponential and logarithmic functions. Wait, hold on. E is such a number such that derivative is the same. Hold on. I don't understand why it's so laggy. Derivative of f of x is a limit and then h approaches 0. Now if we do b of x is then equal to, because b to the power 0 is just 1. Hold on. And then what's the other definition? And then wait, let me check something. I need to see the definition of E. I know E is defined as such a number that derivative is itself. And if we do hold on, in the present now, I'm getting confused. Um, wait. Right, this website load. Definition of E. Yeah, the P of x is taken out. Then you want to find the derivative at 0. Oh, I see. So E is a number such that this would be equal to 1. And then this. Yeah. P to the power of x E ln, because these two will cancel each other out. And then the derivative of P to the power of x so the derivative of the outside, which remains the same, times the derivative of the inside, which is basically this is a constant. And yeah, the derivative of x ln of b is ln of b. So then this is equal to, we simplify this. Now going back, wait, hold on. differentiation of log. So y is equal to p of x, and then whoops. Log x is equal to derivative of x and derivative of p of y is like that. Why is it ln? Oh yeah. Derivative of p of x with respect to x is this. Derivative of respect to this is and I can expand out y. So what am I left with? Just x? Yeah. Time for exercises. Oopsie. F of x is ln x cubed plus 3x minus 4. So the derivative is derivative of the outside which is 1 over then ln of e is just 1, then derivative of the inside plus 3. Right. Next one. Then the derivative of this is low d high minus high d low then derivative of plus 2 is just 0 upon bottom squared. This and then this, these two cancel, and the derivative of this is I forgot. uh, 3 then ln of 3. Oops. Is this the correct answer? Yes, it is. Okay, this one is more difficult. Um, okay, this is going to take some time. Low D high minus high then D low upon bottom squared. Before I do this, I find the derivative of this first. So derivative of the first times the second plus the first times the derivative of the second. And then find the derivative of this. Derivative of the first times the second plus the first times the derivative of the second then what? Is there a way to simplify? Oh wait, it would be easier if I took the ln. Then this divided by 2 minus x, then minus 3 now what? If I derivate derivative of the outside times the inside, and then this is equal to derivative of ln of x is 1 over x plus it with derivative of ln 2x plus 1 is 1 over 2x plus 1. Derivative of the outside times the inside. Derivative of 2x is just 2, but the bottom and top will cancel out. Then minus 1 sine x. Derivative of sine is cos. Then this is equal to, is there another way to simplify? Nope. I'll just write y. Okay, let's do some of the questions and then I think I will end the stream there. So derivative is derivative of the first times the second plus the first times the derivative of the second. Is that it? 331. Yep. Three, and then derivative of all this, which is the same. Derivative of the outside times this. Why is it so laggy? So derivative of the first times the second less the first times the derivative of the second, which is just x squared. Let's do 345. F of x 2 to the power of x times it with log, let's write g of x. Then g of x is 7 x squared minus 4. And then derivative with respect to x is derivative of the first times the second plus the first times the derivative of the second. Now let's find the derivative of this. You know why it's which is 1 over what? Ln of 3 like that. Seven x squared minus 4 derivative of this is times it with ln of 7 and then derivative of the inside, which is 2 of x. Let's see the answer. 3, 4, 5. Okay, the first part is correct. Oh, this cancel out, so yes. We'll do one more question, then I will end it here. So population time t is right. So p0 hold on, in 2000 was approximately 500,000. Assume the population is increasing at a rate of 5% per year. Write the exponential function that relates the total population as a function of t. What is t? T as in number of years after 2000. So t0 at 2000 it was this, and then at at 2001 is going to increase at a rate of 5% per year. So times it by this is now now what? Five plus it with say like that. This and then P2 will increase by 5% again. Which is this square P0 and then P3 cubed 0. Basically PT T P0 in 10 years would be 4447. What number is it? 359. Now we have to determine the rate of the population itself. So the derivative of this would be ln is this correct? So this would be I'm using a calculator, so yep. Okay, guess I will end the stream here then. I think I will do Japanese stream in the evening, but let's see. Okay, then see you next time, I guess.